pleasure to be your host this evening and to introduce our speaker. The speaker this evening is Professor Gilberto Artioli from the University of Padova. And I think Gilberto and this talk represent very much what, in my mind at least, is what New York University Abu Dhabi is all about. Because what you're going to hear about is the way science is contributing to the understanding of cultural and historical heritage. And it's almost the marriage of what C.P. Snow once called the two cultures, the scientific culture and the humane cultures. And there are very few of us who have the privilege and the talent, really, to be able to work in those two areas and to cross from one to another as easily as Gilberto does. He was born and raised in Modena, which not only gave us our speaker this evening, but as many of you know, gave us Pavarotti and balsamic vinegar, of other things. And after completing his undergraduate degree at the University of Modena, he went to the University of Chicago, where he did his PhD in geophysical sciences. So he's a geologist by training. He and I are colleagues because I'm actually a crystallographer, and crystallographers study crystals, and that's where Gilberto has done a lot of his specialization. After completing his PhD in Chicago, he went back to Modena and then took a position in the University of Milan, where he became a full professor. And about a little over 3 years ago, he moved to the University of Padua, where he's also now a full professor of geophysical sciences. He spent a lot of his career crossing between the preservation of cultural heritage and really pure research in geophysical sciences. But in the first of those, that is in the preservation or the use of scientific methods in cultural heritage, he's written the book, which I happen to have here, published a couple of years ago by Oxford University Press. It's a unique book. Nobody has ever done that before, and it's become already the classic in the field. In 1991, two hikers in the Alps discovered serendipitously, a true serendipitous discovery, almost the way Isaac Walpole described created the word serendipity in 1754. They were out hiking in the Alps, and they discovered the frozen body in a glacier that had melted. And the research on that discovery has provided a tremendous amount of information on anatomy, on culture, on anthropology, on the way our ancestors worked and survived. And that's the story we're going to hear this evening. Gilberto was very much involved in carrying out some of the fundamental and basic research, and I think you're going to hear a very exciting story about that research and what we've learned from it. Professor Artioli.
Thank you, Jules, for this introduction. I mean, it's very pleasant to be here, and I'll try to summarize, what we have learned from this frozen body, and which is not only a peculiar example of scientific research, but it's putting many of the scientific techniques to the very much edge. To what the limits and pushing the limits of investigations. What I'll try to do is to summarize what the more recent research have been providing as data, some of the interpretation, and then we can discuss a little bit about that. Right, so the starting date, as Joel said, is September 1991. Two persons, mountaineers, hiking very high at over 3,000 meters in the Ötztal Alps, very close to the Austrian-Italian borders. They did find something in the melting ice. As you might know, for these recent climatic reasons, the glaciers in most places, but especially in the Alps, have been decreasing steadily in the last 40 years. And it's amazing to see that some of the wiring passages built in the early last century are now 30, 40 meters above the glaciers now, and they become very difficult passages technically. This is the place, so it's actually the point where it was discovered, that it was hiking. And just to locate them, it's on the watershed between Austria and Italy, and it's very close to the peak of the Similaun mountain. This is the highest one, around the small valley that was enclosing ice with the body. This is the early photographs of the corpse, and still entrapped into the ice on the first day of the discovery. And this is the elderly couple from Stuttgart that discovered the body. And this is the sign of the crime, the scene of the crime. You see the body, and you see scattered objects, many of which we will talk about. They left the body, of course, and still encased in the ice. And a few days later, two real alpine men, Reinhold Messner and Hans Kammerlander, of course you might know them, they had the opportunity to pass by and have a look at the body. And Messner already released an interview saying that the corpse might be much older than expected. The first sight, the two mountaineers went to the police and said that there is somebody, died in the ice. Might be a skier or a mountaineer or a few years. And Messner said, no, I think it's older. I mean, it might be a few hundred years old and maybe 1,000. And the journalist was worried about the reputation of Messner, and he actually changed the 1,000 year into 10 years in the article. But he was well aware that there was something going on. On day 5, a rescue team from the Austrian Institute of Forensic Medicine actually climbed to the place and extracted the body from the ice. I won't go into the details, but there was ample damage, especially to the left hip of the body, as you can see. They packed it all together in a plastic bag with some of the scattered objects around, without even realizing how much, what they were doing exactly. They actually thought still that it was, a recent body, and they would, put it into the forensic for autopsy. The real, the person that realized that was something exceptional was Conrad Spindler, that looked at some of the objects. He realized that the axe was of an archaeological typology known from the Copper Age. And there are similar axes to the left here, and they are called the Remedello culture of northern Italy, and they were dated at that time between 2,500 and 2,700 years. And so he said it's definitely at least 4,000 years old, or something like that. So the whole rescue operation then and the analysis of the body changed completely from a normal forensic operation into an archaeological investigation. Here are some of the access coeval in some of the alpine graffiti and petroglyphs that are scattered all over from the Mount Begot near the French border to the Val Camonica, and testifying the use of such weapons at that time. Now, just to put a date on that and see what we're looking at, all the dates on the organic, the body, the internal part of the body, the objects, the wooden handle of the axe, and the scattered objects that we will see are dated by radiocarbon dating between 3100 and 33. So the accepted date is very close to 3200 before Christ. And just to put it into a sort of line time, I just inserted the Göbekli Tepe, that is the first, religious large structure known from the Neolithic. That's about 9,000. These are the underground temples in Malta that are just 400 years before, or something like that. And we are talking about a time which is, few hundred years before Stonehenge 1, the first construction step of Stonehenge, and definitely at least 700 years before the Great Pyramids. If you want to compare it with something locally, it's very close to the Jebel Afet cemeteries that are the early Bronze Age local. So we are talking about the Copper Age in the Alps and the early Bronze Age here. That's about the same time. And it's at least 700 years before the first settlement here in the area at al-Nar. Now, the first problem that arose, very legal and very challenging, is Ötzi Austrian or Italian, by finding, because the boundary was actually designed on the watershed in 1919, just after the Second World War. And at that time, the whole area was under a thick, by 20, 30 meters of snow. So nobody actually saw the watershed exactly, and they measured it. So that's the first thing they did, because the Italians, of course, claimed the body as soon as they realized it was fairly important. They redid all the measurements just a few weeks later of the discovery, and it was already the winter and very cold, but they did it. And they discovered that it's 92 meters inside the Italian border, and they claimed the body. So we redid all the whole measurements on the original boundary that was, of course, never checked after the First World War. Good. So once they realized it's Italian, they claimed the body from Austria, but they said, Bolzano is very much German-speaking and friendly with Austria, so they said, it's fine, it's ours, but you can study it. So they left it there in Innsbruck for the first investigations, and until they prepared a whole new museum and climatic chamber, as you will see, to properly preserve the body and host adequately all the objects. But the people from the Ancient Monuments Office, they climbed that back in the next year for two different survey operations, and this is, to my knowledge, the first very high quote archaeological survey carried out. They checked carefully. They found more pieces and more objects that were not found in the original rescue operation, and they mapped carefully all the, of course, the stratigraphy and all sorts of objects that we will talk about. Now, the first thing is how did he got mummified and how he got up there, and these are the basic questions that were asked from the beginning. In the beginning, the claim from the Austrian team was that he probably climbed up there was this foam, this warm wind that dehydrated the body, and that was subsequently buried in ice and snow. Now, the very recent investigation of bacterial DNA from some of the soft tissue, especially the muscles, they testify that was as soon after the death, rapidly covered with snow and ice. It was then undergoing a cycle of thawing and desiccation, but in very cold and humid conditions. And this gave the clue on how to preserve it. I mean, the conservation has built a chamber that is kept at -6 degrees and relative humidity of 98%. And this is how it is constantly kept. You can walk around the chamber and look through, like you're seeing in the picture, and it is defrozen as you're doing in your microwave. I mean, for 1 day every 5 or 6 years, especially for scientific investigations. So once in a while there is a rapid, defreezing and refreezing again for the prelevation of samples. This is one of the team carrying out some of the analysis. I think that the checkup that we made on Ötzi is probably much more than anybody alive underwent in his lifetime. Now, talking about the body, it's this is the silhouette. It's not very nice, but it's informative. It has over 50 tattoos, and we'll look at some of them. This is some of the investigations. I will talk more about more things. But there was a very careful investigation of the stable isotopes in the teeth and the bones to check for the provenances, and we'll talk about that. The DNA was, of course, investigated several times. The cause of the death, we'll talk about that. His last meal, and the pathology. Very recently there were a lot of new studies from samples from the intestines and from the stomach, and that tells a lot about how he was living. And also the pollen attached to the body, inside the body, and on the outside garments tells a lot about the environment he was living and at that time, and we will go through all this. Now, the first thing from the analysis of the bones and the skeleton and the tissues, the best judgment is he had about a weight of 61 kilograms, a height slightly short of 160 centimeters, was certainly adapted to the mobility of rough terrain, like in the Alps and chasing around game and other things. And this is the best reconstruction. This is the second reconstruction done very recently. There was a previous one that is on most of the pictures that is preliminary. These are some of the tattoos. They are around the wrist, in the ankle, in the knees, in the back. Many of the places that are usually hit by arthrosis and back pain and this kind of stuff. So there are claims that these are for therapeutic reasons, at least some of them, and somebody postulated, the use of acupuncture well before the Chinese practice. I'm not sure about that, but I'm reporting. I mean, everything has been said. Certainly, some of the stuff is not just for aesthetic or ritual reasons, and at least the therapeutic, claims have a sense, especially in the back. There are populations still doing that. So, as far as the pathology, he lacked the 12th pair of ribs. It's a very strange anomaly that occurs every once in a while in the body. It does not impair, the ability of move around or any other physiological ability, but that's what it is. He had fractures on the left and right ribs. On the left, they were healed. So they were done during his lifetime and recovered. The last one are fresh and probably produced by the compression of the ice. Or by the fractures that during the last period before he died might have fallen, and we'll talk about that. He had a natural gap between the upper incisor teeth, and that's not very unusual. He was lacking the wisdom teeth, and I'm not quite sure what this means, and if there are any cases of the same population, because there are no other examples. All of the teeth are very worn down, and that's very understandable. It's very common, because he was using the mouth, as most of the primitive population, for grinding, having food polluted by sand and inorganic materials, and from the use of teeth as tools. I mean, when you were preparing ropes and arrows and so on. Now, the Austrian team in the beginning, they did radiography and tomographies, but in 1992 and 1993, they couldn't assess carefully the causes of the death. New tomography done in the freezing period 10 years later saw very clearly the arrow that is inside under the left arm in both radiography, and it is certainly the cause of the death. You can see it very clearly. They missed it the first time, but by careful tomographic analysis, you can also see the blood stains and the hematoma surrounding the wound, and you can also tell that it was hit from the left side in the back by the arrow, and that he actually detached the stick of the arrow, leaving the tip inside the body. So certainly he died within a short time due to this hematoma and lesion. One of the major arteries was sewed by the arrow. We cannot tell whether it was hours or days, but certainly nothing more than that. Now, this, of course, stimulated along, the fantasy of the fans of Ötzi. Ötzi, of course, the name derives from the Ötztal Alps, where he was found, and there are even cartoons, trying to depict the fight. He also had a wound on the left hand, so there were claims of, maybe a fight and violent death. Certainly these cartoons are not correct, because nobody attacking the Iceman would leave the axe and the weapons which were so valuable with the body. So he probably was wounded and tried to escape to a high quote, and he died probably by the end of summer. And of course, you can find these accounts in all languages, and this is one of the most exciting, I think, reconstructions that can be done by the evidence found in the body. Now, the recent analysis of the bacteria and the flora from the intestines and the stomach, they tell that it's a normal human endogenous flora, pretty much the one that you have now. And they also found some bacteria from the cholera, the Vibrio, and this is being interpreted recently as the fact that by the end of the Neolithic, of course, there was a group of people living together and spreading the infections, and possibly also extreme contact with the animals, living, especially in high quote with the animals for warming the huts, and during the winter, and this, of course, was spreading the infections much more than in later times. The last meal, you can recover a lot of vegetables and animal fibers from the intestines, and at least 2 groups have been analyzing them thoroughly at different times, and this is more or less the table summarizing what they found. They found a lot of plant remains and a lot of pollens. The pollens are not, of course, just for the food, but also from just contamination. You know, the cleanliness of the food there was not the best you can dream of. And the animal remains are of 2 animals that are peculiar. So there we are locally available is the alpine ibex and the red deer. So it was definitely a meat eater and not a vegetarian. Now, they've been using the oxygen stable isotopes, I mean, to try to determine whether it was really living in the area, was it escaping and actually maturing and living in some other places. And the results are controversial, so they can be discussed. They are based on the fact that the oxygen isotopes are different. You have heavier high isotopes close to the sea, and lighter isotopes as the more you go through the water cycles, and especially if you climb up. I mean, you do have much lighter isotopes. But of course, these are in contact with the rocks and with the water you drink. So the assumptions are that the bone that you analyze, or the teeth, are in equilibrium with the drinking water, so they are homogeneous, and the water is, of course, a mixture between the precipitation and the rock interaction with the water. So these are the results, and there is one part which is fortuitous, that the site of where it was found is actually in an area that is remote from the carbonate rock. So you can distinguish most of the carbonatic rock in the north from the more geologically complicated situation in the southern Alps. And these have different isotopes. And the claim is that these are the isotopes, oxygen isotopes, red, strontium, and lead, from the bones. And these are from the carbonates in the north, and this is from the rock in the south. So the claim from the Müller group is that the oxygen, the lead, and the strontium isotopes that he found in the teeth and the bones are in equilibrium with the southern Tyrolean region, the Ötztal Valley and the Val Venosta, where he probably lived. There can be discussion about that. Maybe if you have questions, we can go a little bit deeper into that. Also, they try to analyze by very novel techniques, by laser ablation mass spectrometry, looking at the development of oxygen and strontium isotopes from the dentin, which is reflecting the adulthood, to the smolt that is reflecting more the young age and is more conservative. And it looks like there is a continuous trend in the oxygen and strontium isotopes, so that there was some migration of the Iceman from lower height to upper height during his living time. This is as far as the isotopes are taking us, more or less. The genetic analysis of they went through different cycles. There was first the characterization of the DNA from the blood that gave some results and was more or less compatible with European population, the contemporary population. And then there are more recent, reconstruction of more than 96% of the genome sequence of the Tyrrhenian Iceman with from 2 different groups. And the analysis, which is fairly complicated and of course prone to interpretation, tells that actually the Iceman has some relationship with the population that are now confined to Corsica and Sardinia, and that had no other, parenthood up to now. We can discuss about that. Would be nice to see that these populations are not coming from nowhere, but they are somehow related to ancient population within continental Europe. At least would give us some hint about migrations. And some of the genomes apparently tell us that he had brown eyes and belonged to 0 blood group, and he was lactose intolerant and was infected by Lyme disease. So we are entering into the pathology of the body and discovering a bunch of things other than the normal DNA sequence, basically. It's not the modern Lyme disease, but streptococcus, which is similar. A precursor of that. This is Corsica and Sardinia, and if it is related, I don't know, I'm not totally convinced about that, but there might be some relationship. Now, he had, beyond the body, he had plenty of tools that were scattered around, some very close to the body and some as far away as tens of meters. Let's start with the dresses. We have the full reconstruction of how he was dressed. He had a hide coat made of goat skin. He had a loincloth made of goat's leather on both legs. He had a bare skin cap, furry, and 2 separate leggings that he was still wearing, trapped in the ice, made of domestic goat hide. He had shoes. And these are the oldest shoes that are known, and they were made of straw and ferns packed together and covered with animal skin and roped together with a net made of vegetables. And from the left foot we only have the net, from the right foot we have the whole evidence. And so we can reconstruct, the whole dressing of the Iceman from the underneath to the top. In the top he had this straw mantle that was covering the whole thing, and of which large parts have been recovered. Concerning the equipment, he had a belt made of calf's leather with a lot of ropes and different things, and a pouch attached to the belt that contained a flint scraper, a drill, a flint flake, a bone hole, and a mass of fungus that contains these are kind of fungus that deposit sulfides, pyrite. So there are very fine particles of inorganic sulfides among the dried mass of the fungus, and when this is hit by flint, it sparks. Okay, and that was the lighter and the way he was lighting the fire at his will. He had belts with stripes with these masses of polyphore fungus that is partly known to have antibiotic styptic effects. So maybe he was carrying with him a few medicaments. Okay, he was carrying some of these, first aid kit with him around the Alps. He had attached to the belt this white circle disc of dolomite, carbonate. Nobody knows what exactly was for. I mean, maybe it was an ornament. It was, used to strip up the belt quicker than just ropes. Maybe somebody postulated that the central, hole was to straighten out and clean the arrows after he used them. Nobody really knows, and you can make educated guesses as most of the scientists. He had 2 containers made of birch bark and shaped in form of cylindrical, containers, and nets to hang this and keep it together. Well done. He had a retoucher. This is a wooden handle with a rod, internal rod made of deer antler, heated by fire to be hardened enough so that it could chip the flint or wood, as a retoucher. He had a flint dagger with a wooden handle with a sheath, complete set. He had 2 finished arrows with the flints on the top, with bitumen and vegetable ropes to be attached, and a part of the bow that was made of Taxus baccata, and we know that that was very common. It's a very resistant and flexible wood, and that was commonly used at the Copper Age. There are other examples elsewhere that was amply used to make the bow. Strangely enough, inside the arrow shafts, there are a dozen of unfinished arrows, just the sticks, and not without the tip. So it was probably just doing them on the need. The other object of which I'm being, for the investigation of which I've been involved directly, is the copper axe. This is the only copper axe found, prehistoric copper axe, full equipped with the handle, the ropes, and the attachment and everything. So it is the only Copper Age copper axe that couldn't be dated precisely by radiocarbon dating. All of the others are found in archaeological layers, so with some under determination of the age, and other are only dated as surface finds typologically. Some of the archaeologists, when they saw this axe, as Spindler and others, they thought it was at least 800 or 1,000 years later from the typology. So this axe alone revised the chronology of the Copper Age in the Alpine region of about 1,000 years. Now the first question that they posed to me is, how was it made? Because without studying the axe, some of the archaeologists, they started replicating the axe by casting and hammering it around. And they were, by being able to replicate it, they were perfectly convinced that it was cast and hardened, and as many of the later axes. The problem that we faced is that we couldn't touch the object and actually do a full metallographic analysis. And for that time, that was fairly complicated. So what we did is to divide. Usually, metallography is performed by looking at the grains of the metal. You check that with optical microscopy in reflected light, or with other techniques like electron backscatter diffraction. I'm not going into the technical details, but you need to actually polish and etch chemically some of the metal, to show the border of the grains. And we could, of course, not do that. So, why is the grain shape and strain giving you some information? Because the shape of the crystals, and hence my crystallographic background, they tell you exactly what's happening during the thermal and mechanical path of the metal. If you cool it from the melt, you get these dendrites, and whatever you do later, it's recorded in the metal. You can strain it directly, and you get some features. You can reheat it, and you change the shape of the grain. You can heat and mechanically work it, and you see that. And you can do this several times, and you see it. So there are possibilities of, it's called metallography, of interpreting the nature of the object from the metallurgical analysis. And in the past, what they did is actually this. I mean, these are pieces from the museum. This is especially important because of the same age of Ötzi. This was found in a necropolis in the Po Valley in the late 1800s. And you can see the hole that they did in the end of the 1800s, just to analyze it chemically. This is a hole that the Germans did in the 50s. You can see it from the size. This is another Italian team that made another hole in the 70s. And incredibly enough, there are no published data from this axe. So this is the kind of stuff that the museums are trying, of course, to avoid nowadays. So if you ask permission of sampling an axe or any metal object, they say, no way, okay? Especially with something as important as the axe. So what we did is to check the penetration of different beams into a 2 centimeters piece of copper. And of course, I'm not going into the details, but if you use thermal neutrons, neutron particles instead of X-rays, you can easily penetrate, a few centimeters of iron. And you can do that also with X-rays, but you have to go to very high energies. And that's both of the techniques that we used. We have neutrons and we have synchrotron X-rays available to analyze this kind of objects. And of course, the intensity and the energies are just right to carry out the analysis on each piece of archaeological materials as we need it. In the future, we might have some of these beams available on the tabletop as free electron lasers, but it will take a few years again before they are as efficient as we wish. Now, what the analysis that we made is called textual analysis because we don't see the grains, okay, as you do in optical analysis, but we reconstruct the shape and orientation of the copper grains from the diffraction pattern. Like this, just to show you, this is a diffraction pattern of crystal randomly oriented, and this is a diffraction pattern of a metal that is being warped. You see that the intensity has a different distribution in space, and from that we tell how the crystals are oriented. And we try to show that because it's not an easy way to communicate that if the grains are, randomly distributed, we get this kind of figures that represent the orientation of each crystals in the body. If the crystals are oriented because of mechanical working, then we see the orientation directly in this kind of figures. And this is exactly what I will show you in a little bit. The first thing that we did is to test the technique on a replica. We cast it. We did nothing just by pouring, molten copper and let it cool with dendrites. So you see that these are the dendrites from this piece of things. And when we do the pole figures, you don't see any features because the crystals are perfectly oriented. So that's a proof that is working. But to see what we can do is that we take the same piece of metal that we produced, start hammering and heating it for several cycles, and you see the pole figures coming out. So we are doing the reverse. That from now on, in the real objects, we don't see the metals, the grains anymore, but from this, we are convinced that we can extract the original working path of the objects. The problem is that we had nothing to compare to, okay? We had the Ötzi that we analyzed in Grenoble, and so I asked the archaeologists to pinpoint at least 20 coeval axes from different museums that they thought was about the same age, so that we could do some statistics, and compare to something. Otherwise, when you have data and you don't have a database, interpretation is null. And this is one of the axes that they've been pointed out. It's coming from the museum in Bolzano again, and is being put in the pot and irradiated with neutrons. It's totally non-destructive. Okay, we go through the object and we don't damage at all. It gets, if there is a little bit of silver, it gets a little bit of radioactive, but then you wait a couple of weeks and that goes back to normal. You can put it in the museum. And this is some of the results. I don't go into the details of this stuff because it's getting very complicated, but we analyzed all of the references that archaeologists were giving us. They say, like, I think it is like the Remedello tomb 102, so we got that one. I think it's very similar to the one that is in the museum in Bellinzona. Okay, go and get the stuff and analyze that, okay? And to tell you how refined is the stuff is that we can see also the difference between the body of the axe and the tip that it was more worked. We can analyze any one of these features very carefully. Right. The summary is that many of the axes are different from one to the other, and to tell you how far we are going into the interpretation, these are the measured pole figures for this axe. This is the computed one. I mean, these are absolutely coincidental, and we can go for a very safe interpretation of the stuff. Let's see. Okay, of course, we dismounted that, brought it to Grenoble, analyzed it, and let it go back to background radiation in a matter of hours, actually, because it contains less than 0.3 silver. And there is absolutely no feature. And this was the final proof that it was cast and not work hardened at all. Actually, if you do an energy scanning with X-rays, synchrotron X-rays, you see that the grain size in the millimeter near the blade is much finer, small grains randomly distributed. If you go inside the body, you have large grains, again randomly distributed, but very large. So this is just for the use of the axe, okay? It was soft metal, cast, not hardened, but it was used. I mean, the crystallization in the blade is not being done by, mechanical hardening, but just by use, repeated usage of the axe. Now, overall, out of 20 axes that we analyzed, there are 15 that are little mechanical working, let's say less than 5–10%, but they are always thermally annealed. All of the copper axes in this period were used in the soft state. So it's a metallurgical contradiction because we think out, we harden the metal, but the axes were used in soft states because ductility, was much more important than hardness for the axes, not for the daggers. Two of the samples, the Iceman and another axe, are untouched, just in the soft as-cast state, cooled in a bivalve mold, and that's it. And three of the samples have been slowly cooled in a warm bivalve mold and let it cool very gently so that the crystal is ice-oriented. They are almost a single piece of a single crystal. So the 100% of the axes we analyzed from the Copper Age are in the soft state. And we think that the axe was amply used and was much more important ductility and deformability of the metal, that being able to reuse. It deformed, you put it into shape, you heat it again and reuse it many times, with respect to the previous, Stone Age axes that, once you break them, you have to redo them completely. They knew how to make hardened metal at the same time because some of the daggers, which are coeval, are made of alloyed copper, arsenical copper, not thin copper, and worked. So they knew perfectly how to do it, but for different purposes. Now, with the replica of the Iceman axe, I personally fall a tree of 30 centimeters diameter in half an hour. So it's perfectly workable, okay? And you can certainly smash a head, no problem, even if it's in modern terms soft. All of this stuff, of course, has hit the fantasies of Ötzi fan. There is a musical made in German-speaking Bolzano, the man from of the ice. He has a Facebook page if you want to hook up and be a friend of Ötzi. There are apps for kids, unfortunately just in Italian as far as I know, but they will develop rapidly. There are games, these frozen freights, so you can answer questions and play and try to mimic all these last steps in the last month or weeks or hours before his death. And I'm not sure that the more recent reconstruction is actually how it looks like, but it certainly has opened up, a window in the Copper Age that we didn't have before. Now, with this, I thank you for your attention, and maybe we can, look at the trailer of the. I wanted to show you a trailer of the musical. Right, thank you very much.
Hi, I'm Sohan from the Masto Institute. I was wondering, he seemed to be of a more settled culture, it would seem. I think maybe I'll stand up and see me.
Yeah.
He seemed to have come from a very settled culture, judging by the domestic goat and stuff like
Absolutely,
that. Absolutely,
yes. Do you think?
Well, sorry, I just wanted to ask about whether whether he was close to where his settlement was. Can you tell that?
Yeah. Putting together the information on his not moving very far during his life, and the pollen analysis says that he was living nearby in the last months, the stuff he was eating. They think that he was living nearby in the lower valley, basically, 2,000 meters below, and didn't move very far during his lifetime. Certainly, we have evidence that the Alps were, heavily inhabited already in the end of the Neolithic, early Copper Age.
Hello, thank you for a very interesting talk. My name is Dr. Mark Beach. I'm from the Tourism and Culture Authorities. I'm an archaeologist, so I was very happy to enjoy your talk. I was interested that you mentioned that he had Lyme disease. I know that there's all these many papers published on them, but I wondered if you could talk a bit more about that, because I remember I used to work in Prague in the Czech Republic, and my boss actually had Lyme disease because he spent a lot of time in the forest, and it's from ticks, and especially transferred, I think, from deer and
right now, yes,
like
and possibly the transmission at that time was the same. But as far as I know, this is the first time we got an ancient, evidence for Lyme disease as of.
Yeah, that was my next
of this
question was actually, is this the oldest evidence for
As
Lyme
far as I
disease?
know, yes, is the oldest evidence. And now there are a couple of groups, especially in Britain, that are looking for ancient disease, and trying to prove, the evolution of the species and the transmission.
Because I would
through
imagine
time.
there would be earlier evidence for Lyme disease because of course, the Mesolithic peoples were interacting a lot with deer and with forests and environments, but just we haven't found it yet. But I can't think of an earlier example so far, although there are some Mesolithic Scandinavian.
It's the oldest mummies, so well preserved that you can definitely get pieces out and complete genetic information. That's the problem. You would hardly find anything of this age or even older that preserves the stuff. I know that, I can't remember the name, but there's a group in England trying to extract some of this genetic information of bacteria from the bones. Okay, they seemed to have isolated the tuberculosis one very far back, even from the Neanderthal. I'm not definitely nothing like the full sequence of Lyme disease.
Thank you for your informative presentation. Just I'm wondering, how did you measure or assume that his weight and his height, especially when he covered by the overburden ice? Does the overburden ice will affect, or it will shrink the Iceman height, and does it will affect the texture of the copper axis? Does it have any?
No. Okay, two questions. Concerning the body is just not me, it's forensic operation, okay? That's the people measuring the bones, and they, and from the height and the bones, they estimated that the body mass was about that one. Nothing to say to do with the actual body mass, of course, that is being, mummified through the cold conditions. And certainly the ice didn't have enough pressure to change anything in the axe. Okay, the metal is formed at high temperature and partially recrystallized with the normal use, heating, but certainly not from the pressure of the glacier. Okay, there might be some consequences for the isotopes. Okay, I talked with Muller and I told him, I think what you are finding is just, equilibrium with the melt of the glacier. And he said, I hope not.
Thank you.
Hello, again. Dr. Zink was here last week, actually.
Oh.
And he was here, he gave a presentation on more of the biological aspects. I liked what you talked about the copper and everything. That was a nice set.
Well, I'm in the inorganic part, so.
So yeah, I actually, he was, he also showed a slide that showed this reconstruction of his face and his body, this exact one. But he seemed to not like the reconstruction of the Iceman as being a wizened old man with lots of wrinkles and graying hair and beard and all that. So just wondering what your thoughts on that. Is that accurate?
I'm not an expert. I don't claim. I'm just showing what the most recent, reconstruction it is, and they added the brown eyes and the reddish, hair, this kind of stuff from the genetic sequence. So every time they get new data, they try to improve the reconstruction. But I think that the physiognomic, is totally, up the wall.
I just wanted to know that, we talk about their axe and daggers, and they were molding it. So what fuel they could be using in that environment to get so high temperatures?
To this I can answer in details if you want, because we are heavily studying the earlier copper metallurgy in the Alps. We are not exactly about 3200, but let's say 2800 before Christ. We already have slags from copper extraction from sulfides. So the technology was very well advanced. They knew how to get the copper not from the oxide, like for example in Timna in Jordan or other places where you do find native copper or oxides. It's very easy to extract and reduce the copper. When it's in the copper oxides, you need to reduce the copper and oxidize the iron at the same time, and so you have slagging. It's a much more difficult operation. It's not difficult to reach the temperature. With a simple crucible and bonfire, you can reach 1400 degrees, no trouble. The difficult thing is to control the oxygen fugacity and control exactly the amount of charcoal or wood that you're using and the airflow. That's the combination. This is very tricky.
I have a small question. I'd like to know if you have done any DNA test, and if so, does he have any relatives now we can refer to them? And then how could you find his age? How did you guess his age? And was he married or not married also? Thank you.
The age again is mainly derived from the body constitution and the bones. I mean, the teeth, they tell you a lot about the evolution of a man. The genetic sequence that I showed has been done by 2 different teams. The last paper has almost complete genome, and from the the analysis that they're doing, they say that it is compatible with the European population that we know, and that more recent time, because that's the oldest example that we have. And the closest clad, is this Sardinian strain. I don't believe it really, but I mean that's one of the interpretation of this part of the sequence.
So you mentioned that the axe is very valuable. So
Yes, absolutely.
Yes, I imagine it would be. So anybody tried to estimate, like in today's money, how much it would have been, and correlate that with this person standing in the community? Like he carried not only the axe but a lot of other stuff. So what does that say about where that person was?
Yeah. That is a difficult question, because as soon as they found it, and that's the archaeological interpretation of most of these things, is a status symbol. Okay, it's a special object. It was a chief. It was whatever. From the rest of the analysis, it was a poor guy traveling the Alps, trying to get to find his own food and living nearby and escaping from death, from I don't know, tribal fight or whatever you want. So certainly the axe was not, I think, a chief object or anything particularly special. It was valuable because copper was, it has been one of the motor of economy. I couldn't put a value, but certainly was a very valuable object. That's why I said that he couldn't have been killed and left the axe nearby. He was certainly hit in another place, and then he tried to escape and left the objects. Absolutely, yes. I would say more than your car, probably.
We heard that our grandfathers and mothers were tall men, but that one we saw that he is 158. What your opinion? Is that true that our father Adam and Hawa Eve were 20 meters or like thing like that?
Can
His height was what, 158?
This
were
one is
our
short.
Ancestors, did you ask, our ancestors, were they that tall or?
Because they returned back to be short men and then tall.
I wouldn't generalize the stuff. I mean, he was certainly 160, and probably the population. If we had more examples, their population in the Alps was about that. This is, for example, compatible with the genetic sequence of Sardinian people. That is usually bulk and short. So this is actually in accord. I wouldn't generalize because I've seen sequence of, for example, we collaborated with an archaeological expedition in Sudan, and the Mesolithic bodies are much taller than the later ones. Okay, so there are changes in population and in the same site, and interbreeding, of course, at later times, that don't necessarily you go from short to tall in one direction. I mean, there are migrations of population that changed the picture quite a bit.
How much that was the tallest man did you see or heard about that or read?
It depends on which time, and I mean, I've seen a body, sorry, from later Roman times. That they were also fairly short. The Romans were 165, something like that, in the average or less. But I saw a body from Calabria that was 2'10", 2'10". So it was unusually height and the same genetic sequence. So there are exceptions in every as in every population, and there are different developments in different places. The Han people in the equatorial part of Africa was tall and white before the Bosimian population later on, Negroid.
Do you know where the copper came from?
That's a good question. We are working on that. When we analyzed it for in a non-destructive way for the making of the eggs, they actually asked, can you tell us for the copper? And at that time I said no, because I have no database to compare to. Since it means 8 years ago, we have been building the database, and now it's ready. I've been able now to definitely prove objects of the same, and all these legs from the Alps, we know exactly which mine is coming from. So the next step is to go back to the eggs. But this time will be micro-destructive, but it must be destructive. I have to get some atoms out.
Why don't you believe that Otzi is related to present-day Sardinians?
No, I find it funny, but it's entirely possible. What I said about the stature and, the overall constitution, and what apparently the genetic sequence is telling us is that at the present status of knowledge, it is like that.
My question is, do you know what was the dominant oxygen isotopes in his body? Because that will interpret which environment he lived longer, whether he lived in the mountain or in the sea.
You cannot get the oxygen isotopes from the soft tissues because they exchange with the water, of course. So they're not reliable. They are in equilibrium with the glacier, the ice oxygen. So you get, or Mueller tried to get it from the teeth and the bones because it's more conservative, and possibly it tells you something about your life. Okay, it didn't exchange later. Okay. Thank you.